In our last lesson for topic 4, 4.5 has us solving rational equations. This process will be slightly different from adding, subtracting, multiplying, or dividing. When asked to solve, you'll have a couple of scenarios to work through. In examples A and B, we have just one fraction on the left and then a whole number on the right-hand side. To solve, we'll follow these 3 easy steps. Steps 1 and 2 will sound familiar to you. You'll want to factor if possible, as that will help you determine your restrictions in your domain. So we'll just say state restrictions. And then the great thing about when having one fraction on each side, or one term on each side, is we'll just cross multiply to solve. And we've already done that a couple of times in this topic. For example 1 on the right, example A, what is the solution to the rational equation? We have 1 over x plus 4 is equal to 2. Well, if we have a fraction on the left, let's make 2 a fraction on the right by writing it as 2 over 1. Now to factor, there's nothing to factor in this problem, which is really nice. So we'll just state our restrictions. In the denominator on the left, we have x plus 4. What that means is x can't equal -4. When we're done solving, we need to make sure that our answer isn't a restriction. From here, now we just cross multiply. 1 times 1 is 1. Super easy. 2 times x plus 4. Let's make sure to put the x plus 4 in parentheses, and then to eliminate them, we'll distribute the 2 in. That gives us 1 equals 2 times x plus 2 times 4, which is 8. To get x by itself, let's move 8 over by subtracting it. 1 minus 8 is -7. And now our final step to getting x by itself, divide both sides by 2. So the process is pretty straightforward anytime you have just one term on the left and one term on the right. You guys try example B. Pause the video, follow the 3 steps. When you're done, press play to see how you did. For example B, if you got 16 over 5 or 16/5, then you would be in good shape. My denominator restriction was x can't equal 3 and 16/5 doesn't equal 3, so we've solved our rational equation. When asked to solve equations that have more than one fraction on each side, the process becomes a little bit more challenging. At least the first 2 steps will stay the same. Over on the left-hand side, we'll write multiple fractions at the top. And then this will be the process to follow when it's not easy enough just to cross multiply. Now step 1 is going to be to factor again. So again, that process should be the same for you. And then state your restrictions. It's step 3 that'll be kind of unique to us. Step 3, we're going to find what's called the least common denominator. So I'm going to write LCD for least common denominator. Just like you'd be adding and subtracting fractions with plain numbers, the least common denominator is the smallest amount that all the denominators would go into evenly. And then what you're going to do with that LCD is you're going to distribute it on both sides. What that does is it cancels out all the denominators. It's kind of cool. So distribute on each side. Once you do that, all the denominators, whoops, not sewed, we want side. There we go. So again, once you've done that, all the denominators will be gone, and what you'll have left over is what happens like when you cross multiply. From here, now you just solve like normal. All right, so let's see how this process works. Over on the right-hand side, what is the solution to the equation 1 over x minus 5 plus x over x minus 3 equals x squared divided by x squared minus 8x plus 15. I don't know what happened there. Now again, remember you guys, we can't just do this. That's a bad idea. The reason we can't do that is because x squared on the bottom is part of a bunch of other stuff. So let's remember to not have that happen. What we will do instead is follow those 5 steps on the left-hand side. Step 1 is to factor. I notice x minus 5 is all by itself. There isn't anything to take out of those two terms. X minus 3, again, we're good to go there. But x squared minus 8x minus 15 will actually factor into x minus 5 and x minus 3. Looking at all my denominators, I notice that there are 2 parentheses of x minus 5 and 2 parentheses of x minus 3. What that means for our restriction is that x can't equal 3 or 5. And then step 3, that least common denominator, the LCD. What you're looking for is the most amount of times you see a parenthesis or an x or a number in any part of the denominators. Well, I notice I see x minus 5 once here and once here. What that means is you only see it at most one time under any denominator. That's going to be part of the least common denominator. I also see an x minus 3 once on the left and once on the right, but I never see it in a fraction more than once. Therefore, x minus 3 is also part of the least common denominator. Now watch what happens in step 4. I'm going to write the least common denominator, x minus 5 times x minus 3 over 1. And what I'm going to do is just rewrite the entire equation, 1 over x minus 5 plus x over x minus 3 equals x squared over x squared, or actually x minus 5, x minus 3. I'll put it in that factored form, and that'll help us when we distribute. What happens now is I'm going to take this entire group and distribute it to the first term. In that first term, we have x minus 5 on top and x minus 5 on the bottom. What that means is they cancel out, and we're left with 1 times x minus 3. If I distribute it to the second fraction, now I've got an x minus 3 and an x minus 3. They cancel out. We're left with x times x minus 5. And then we have equals. When we distribute that pair over on the right-hand side, notice we have x minus 5, x minus 3, and we have the exact same denominator, x minus 5, x minus 3. So they cancel out completely, leaving us with just x squared. It's almost like a cross multiply because now we have no denominator. Step 5 from here is to solve. 1 times x minus 3 is just x minus 3. Plus, we have x times x minus 5. I have to distribute that in to eliminate the parenthesis, and that would give us x squared minus 5x. On the right, we have x squared. So notice anytime we have a quadratic, typically what we would do is we'd set our equation equal to 0. But if I move x squared over, now they cancel out. That's awesome. That means we don't have to factor or do quadratic formula to solve. What we have left though, I've got an x minus 5x. That means there's a total of negative 4x. And then we've got that minus 3. And on the right-hand side, that equals 0. Thinking about how to get x by itself, if we add 3, that would be negative 4x equals positive 3. Divide both sides by negative 4, and x equals negative 3/4. And that's the solution to the equation. We'll talk about extraneous solutions and our application problem tomorrow in class.